What is your return on technology? Now, if you've never been asked this question before, or you're wondering if you're in the wrong place, you're actually in the right place. So here's the setup. First, these episodes are our attempt to make what seem to be complicated topics easier to understand. Second, one of the things that we've discovered along the journey of our research and modeling is that it doesn't really matter what your company spends on technology. What matters much more than that is, what do you get for your investment in technology? What's the performance versus the investment? So we started to lay down the groundwork for this story in episode 2, Measuring the Pace of Automation, where we went into some detail about the only three data points that we use in cases where we have observable technology spending data to develop analytics to measure and benchmark this idea about the return on technology. So in those cases, just as a brief review, all we're looking at per company, per period, and we're talking about banks and asset management firms and trading firms and brokers and others, is the difference between the performance, in this case revenue per employee, and the technology cost of that performance, in this case technology spending, total technology spending per employee. And we start to lay out this framework, this benchmarking framework, which we call the T-Greeks, given how prevalent the use of the Greek alphabet is in describing phenomena and situations in the markets, like alpha and beta and delta and gamma and so on. So the core analytic, the first analytic that we're going to look at to describe this framework and answer the question about what is your company's return on technology, we call T-spread. And the T-spread is simply the difference between revenue per employee and total technology spending per employee, per company, per period. Now, we've done this analysis in our initial global banking study, where we modeled 60 of the largest banks in the world and developed these analytics for each of those banks and each of those models, each of which begins in 2005 so that we could capture whatever happened slightly before and since the global financial crisis. So now we have an 11, 12, 13-year time series per bank. So we start with this T-spread. The next analytic in the framework is called T-beta. And for those of you that know market jargon well, this is really the community, what the consensus of the community produces in terms of this spread between performance and the cost, technology cost of that performance. So we collect the T-spreads, in this case for a community, a sample of 60 of the largest banks in the world, 16 countries, 11 currencies. And we create a scatter plot of that data. And the best fit line, which is automatically produced by your Excel spreadsheet, is the benchmark, is the T-beta benchmark. This is the consensus of that community for each point of scale along the spectrum of the sample that we've modeled. So that's the second analytic, t-beta. The next step in the process is to look at, well, who's ahead of that benchmark and who's behind that benchmark or below that benchmark. The first of which we call T-alpha. That's a situation where it can be described that you are defying your scale, that you're punching above your weight class, that you're generating more performance given your investment in technology per employee relative to the sample. So sometimes you hear us use the term technical leverage. And this is a case where the technical leverage is beyond that of the benchmark, of the consensus of the community. Of course, the opposite of that is tech debt. You have an excess of legacy technology that weighs down this T-spread. We call that situation t-theta, where you are betraying your scale. You're not getting enough given your investment. Now, so that's the first four analytics. There's one more in this framework, the T-Greeks framework, that we call T-vol. And this one is a little bit different. This one looks at the volatility, the variance of T-spread over time. So this is a way to look at the volatility as measured by standard deviation of T-spreads over the time series for a particular bank. In this case, as I mentioned, 11, 12, 13-year time series. So with that, when we compare the standard deviations, the T-vol, of a particular bank with that of its peers and competitors, we can rank those and develop some hypothesis about the meaning of that. Why is there so much variance in T-spread? Now, given that there are three inputs to the T-spread, revenue, headcount, and technology spending, we can't automatically conclude that the variance in T-spread is a result of some wildly changing movement or lack thereof in underlying technology spending. It could be caused by massive changes in revenue or massive changes in headcount. But observing this over time, some players tend to exhibit a high T-vol and some tend to exhibit a low T-vol over this 11, 12, 13-year time series. And so the working hypothesis there is that this analytic may be an indication of some intangible management cohesiveness, cultural cohesiveness, other factors about how the organization is changing and maybe how well it's being managed or how well the team is performing when you put these factors together. So those are the 5 analytics for our T-Greeks benchmarking framework. It's been applied to banks so far. We will be updating our global banking study later in the year, 2018, updated through 2017, and likely expanding the list of models beyond the initial 60 that we've developed so far. For those of you who may want to see a longer form of this discussion and dig a little bit deeper, about a year ago we did a webinar with our content distribution partner, IT Group. That's about a 45-minute webinar that I will post a link to in the setup to this video on our feed. So I want to bookmark it there. I want to thank you for your attention, and I'm looking forward to sharing more of Alphacution Riffs and the work we're doing here at Alphacution very, very soon. Thanks for watching.